This is what the cyborg future looks like. Most everyone is enhanced with technology. Many even surgically upgrade their bodies with powerful bionics. Computerized eye implants not only sharpen vision, but immerse users in seamless augmented reality. Cognitive devices connect brains directly to artificial intelligence, exponentially boosting intellectual capacity. Widespread machine integration is redefining what it means to be human.
My brain is melting.
Today, scientists are blazing a trail to this very future.
These devices are going to make us more powerful, more independent.
I want to know what breakthroughs are being made.
It's a radio that captures your thoughts in real time.
I'm improving the human body by implanting devices into it.
That will forge the future too?
Look, Ma, I'm a robot.
The Cyborg Revolution. My name is Giuffria, and I am a cyborg, a combination of human and machine that acts as one. I was born without part of my left arm, and I've been wearing a prosthetic device as long as I can remember. They used to call me the bionic baby.
This was my first ever multi-articulating hand. It was the big jump from this one grip pattern, this tripod, to being able to change the grip. I flex the muscles. It lets me move the hand.
As my arm muscles move, they affect 2 electrodes resting on my skin, which allows me to control my bionic hand. 4 years ago, I got my current prosthetic hand, and it's been a real game changer. It gives me finer motor movement and multiple ways to grasp things. As someone who started to merge with a machine, I can see that it both defines me and I define it. But I want to find out how cyborg technology like this will evolve for the entire human species. How far will the merging of man and machine go? And what will our cyborg future look like? My first stop on this path to the future is a personal one. At the Johns Hopkins Applied Physics Lab, they are developing bionic limbs even more advanced than mine. Costing upwards of $120 million to develop, the modular prosthetic limb, or MPL, is state-of-the-art.
I'm really excited about today because we get to see the MPL hand system, which is something I've wanted to see for almost a decade. I think I've dreamt about seeing this hand.
Engineer Robert Armiger is combining robotics, neuroscience, and artificial intelligence to make devices that will change lives around the world.
It's here in real life.
That's right.
Unlike my prosthetic arm, the MPL is designed to be upgradable, and it can be customized. It's also more dexterous.
You know, we've really tried to build in to this hand all of the sort of movements of the human hand. To see that each of the fingers is basically the ability to separate or spread the fingers here.
Cool.
These two are coupled together. This one moves independently. The middle is fixed. All the fingers have a drive that flexes each finger, and then they've got this mechanism that allows them to passively curl around an object as well.
That's cool. I didn't know that existed.
It even has a powered, flexible wrist.
I want flexion extension so badly. I don't have flexion and extension. I only have rotation, which is fun for a party trick, but I can't actually bend the wrist. So when I'm trying to put my hand to my mouth and stuff, I have to lift my shoulder. So when I see stuff like the flexion and extension in that wrist, it makes me really excited that I could have it for my hand one day.
Bobby lets me test drive the MPL. First, he places armband sensors on me. Like my prosthetic arm, these bands contain electrodes which record and translate the muscle activity in my little arm.
We use electrodes that can pick up what's called the biopotentials of the human body. It's sort of the electricity that is flowing through your body to send commands to and from your brain.
With 8 times as many electrodes as my arm, these bands allow for much finer pattern recognition from my muscles.
Instead of just picking up like gross muscles, so these big muscle movements, it's picking up smaller, finer things.
Today, I'm getting a feel for some novel gestures and new capabilities.
All right, so when you're ready, so you're gonna start recording with no movement or rest state.
Okay.
And well, it's okay. It's learning the first time, so it may sort of confuse what you're doing because it's never seen this pattern before. You're introducing something new.
A computer inside the MPL reads the muscle movements from my arm and translates these complex patterns into movement in the robotic hand.
This is really cool.
The machine is learning more about me, and fast.
So I'm sending different muscles impulses, like to trying to see how much control I can have over it, of like the slow and fast. I was trying to do this, but that's cool.
This cyborg future emerged through the needs of wounded veterans and other amputees.
Johnny Matheny is one of the individuals that has spent probably the most time with the modular prosthetic limb, and he has really been able to show the capabilities of the arm because he has a surgical procedure that not only allows us to map the arm or attach it directly to his body, but then he's had the nerves in his arm rewired so that his control is natural and intuitive.
So what's next for it?
The fingertips are set up with active sensors inside of each of the nodes. What we've been working towards is some of the sensory feedback or stimulation to your arm, so you'll be able to actually feel what the hand is touching.
Okay. Can I? My brain is melting.
Without any feedback from my prosthetic hand, I can't tell how hard I'm grasping an object.
Like holding a styrofoam cup or trying to grab an egg, right? Where you're like, don't crush it, don't crush it, don't crush it, don't crush it.
The team at Johns Hopkins is working on this very difficult problem. Bobby's colleague, Dr. Luke Osborne, is enhancing the MPL's features with something called the eDermis. This incredible technology promises to simulate the sensation of touch.
Think about how much we rely on our sensation of touch, not just for grabbing objects, but also interacting with other human beings.
Right, yeah.
eDermis was made to mimic the way our natural skin behaves. And essentially, we have different layers, and within those different layers, we have different receptors.
Inside the skin, nerves detect pressure, pain, heat, stretch, and vibration. The eDermis is made from flexible fabric and rubber. And inside of it, tiny sensors detect various stimuli and translate them to the body's nerves.
Try to put it on?
On me or my prosthesis?
On your prosthesis.
Yeah. I've never really had that kind of feelings on the side from like touch and stuff. So it's also like a little scary, but exciting.
When I press on your fingertip, I can see the activity on the screen. So if you were to grab an object, we could see what the sensor activity would look like if you were to naturally pick up something.
That's so cool.
Luke's computer displays the pressure patterns from the eDermis for this sensation of touch. When these same signals are transmitted directly to my nerves, it gives me a sensation I've never felt before. It absolutely blows my mind.
It feels like it's like pulsing over here. This is really cool. I think seeing this just makes me realize that we're on the path of doing some like really, really awesome things.
A bionic hand with a fine sense of touch will change lives and completely reshape the future.
The potential for this technology could be not only used for rehabilitation, but also for projecting yourself into some remote environment.
Like a remote control Iron Man, Bobby imagines a future where an arm like this could be used to perform complex tasks from just about anywhere.
In the future, advanced dexterous bionic arms are a common feature on most robots. These worker bots perform complex and delicate tasks in environments too hazardous for humans. From hundreds of miles away, skilled operators remotely perform nuclear cleanups, fight fires, and even repair the space station from the safety of Earth.
Mechanically enhanced humans have long been popular in sci-fi stories and superhero comics. As a partial machine myself, I'm excited by the real superpowers that our cyborg future will bring. But in everyday life, making cyborg technology work seamlessly with the human body is hard. When it comes to enhancing the human body with technology, balance is essential. Weight, speed, strength, these are all factors that must be considered when designing and engineering wearable robots. At Ekso Bionics, Jason Jones is taking on the daunting challenge of bringing man and machine into sync.
Our main purpose is to enhance human capability through robotics primarily, right? So either for medical purposes or for industrial.
They've developed several true-to-life exoskeletons.
In my lifetime, I think you'll see more of people being augmented by machines. The approach we're taking is instead of replacing people, let's make it so they can do more. If they want to, they can work into older age because they have enhancement.
Jason's colleague, Zach Haas, shows me exactly how their exoskeletons boost worker productivity. This model is already being used in factories.
See how it feels?
I feel like I'm supposed to be really, really strong now.
Right.
Now that I have this on.
This is designed to really give sort of superhuman endurance.
Okay,
Yes.
I'll take that.
There you go. So now as you go to raise your arms, you'll feel it kick in, yeah.
Oh, okay, yep.
Feel it?
Yep. And then,
What's it feel like?
like my arms are like free floating.
There you go, that's the key word there.
This free-floating sensation happens with mechanical spring-driven technology, which reduces strain on the arms from repetitive motion. It's so wild. I can absolutely feel the power and how it would transform industry. But for some, it might be intimidating.
Do you think there's a little bit of fear in the idea of like presenting some of these technologies?
Yeah, a little bit of sort of, there's just this idea, what is the robot? Am I a robot now? Am I working with a robot? What does that mean? It's a machine that we're now strapping to your body.
Right.
And it's got to work with you and you've got to work with it.
A little bit more personal.
A little bit more personal. So yeah, there's definitely more sense of trepidation there, but once people see the benefits, a lot of that disappears pretty quickly.
Look, Ma, I'm a robot.
Not only do exoskeletons boost human productivity, they can also restore locomotion to those who've lost it.
I'm gonna get to meet somebody who uses one of these exoskeletons and has this whole interface with technology like I do.
At the age of 32, Jess McNair experienced multiple strokes and lost the ability to walk.
It affected the right side of my body. It also affected my balance and vision pretty severely. It's been a journey.
With the help of physical therapist Jen Masievich, this exoskeleton is changing Jess's future.
1, 2, 3, push.
So cool. Can you explain to me what is actually allowing you to do things?
There's basically 4 motors. There's motors at the hips and then at the knees. And the ankle doesn't have a motor, but it actually allows us to position her for greater balance.
That's really cool.
So it allows someone to be fully weight-bearing, but also supported in a frame in a proper biomechanical position. All right, Jess, do you want to start the first step with the interface over there?
That's so cool.
An onboard computer uses feedback from sensors in the exoskeleton, and sophisticated algorithms process that feedback and then apply the proper amount of movement to each biomechanical joint. This coordination of man and machine represents a tremendous breakthrough. The exoskeleton is teaching Jess how to improve her gait.
We want them to be able to walk again. We want them to be able to step out of the device with a better walking pattern.
What do you hope to see in your lifetime?
The goal is to make it smaller, lighter, more adapted to the human body and less apparent.
So you want it to be like more of a part of you then?
Exactly, yeah, more bionic.
Exoskeletons like these have humble origins. Early versions of this technology were clunky at best and seem laughable to me today.
One may witness a scientific endeavor to convert a man's legs into those of a giant.
But every evolutionary path must start somewhere, and our cyborg future is advancing fast. The team at Ekso would know. They've also developed exoskeletons to assist with punishing physical outdoor tasks.
Carrying large, heavy loads over long distances or increasing endurance, that kind of thing.
These powered exoskeletons can help a person carry a 200-pound pack swiftly across rugged terrain. Incredibly, the wearer would only feel a mere fraction of that heavy weight.
These here are hydraulic cylinders, and they basically are kind of like a parallel muscle with your quads. So you can press down harder if you're walking up a hill, for example. It'll give you a little amplification. The design attempts to amplify your force, right? So if you're applying a certain amount of force, and it would add to that to kind of offset the effort that you're putting into it.
That's really cool.
In the back, you know, there's electronics in here, and there's a hydraulic pump and control systems.
And then we talk about mud and rain, obviously, the electronics.
Yeah, the challenges they're pretty big challenges in
I have those challenges myself, so.
Future versions of this cutting-edge technology will someday be widespread.
I think in the future, you'll see many people wearing assistive devices on a daily basis. I'm almost certain that those devices will be controlled at some level through interaction with the human's nervous system or their brain.
By enhancing our bodies with advanced robotic exoskeletons, we're taking a step closer to the Cyborg Revolution.
In the future, miniaturized, power-boosting exoskeletons are integrated into custom garments. With the press of a button, superhuman strength and endurance is available to everyone. This body augmentation reverses the decline of old age, restoring youthful vigor to anyone who still has a passion to work or explore.
In our cyborg future, wearable machines will augment our physical selves, and wearable computers will augment our minds with instant access to worlds of information.
I would wear wearables, yeah.
How will advanced wearable computers impact the way that people work, learn, and interact with their world? To find out, I've come to Atlanta to meet a true pioneer in wearable computing, Thad Starner.
For me, the real killer application for these wearable computers is augmented memory. Machines that become part of your mind, give faster access to knowledge, make you stronger in the sense that you have all this information you can use to help you on your day-to-day life.
So this was the first thing you worked on at MIT?
Right. Most people had no idea why you'd want a mobile computer because laptops weren't even out there yet.
While attending MIT, he became frustrated by his inability to retain what he'd learned in class. So Thad built this augmented memory system to take better notes.
You ready?
Oh, I'm gonna put it on.
So bring your fingers around like this. There we go. So now that is my daily suit in year 2000. So you'd have this plus a car phone plus a 7-pound lead-acid battery.
Do I look really stylish?
Actually, it looks pretty good on you, to tell you the truth. Yeah.
Though retro now, Thad's system had a portable computer, typing device, and a heads-up video display over one eye.
I found that once I had the ability to take notes in class, and especially this portable system, I took notes in person-to-person conversations. And that's one thing computers are horrible at right now, is assisting you during this sort of interaction.
Right.
But having a head-up display, you only use it when you need it, and it keeps your eyes in the world around you. And I find it to be really a good augmentation of the conversation.
The heads-up display overlays information within the user's field of vision. The system can be used to access applications or the internet. It can also augment your surroundings with information that only you can see. Thad eventually led a team that turned this tech into a commercial product, Google Glass.
That's the first functional one. We had to glue a cell phone to the side of our head to get a trackpad that worked.
That's wild.
Advanced smart glasses like these are making workers more productive in industries like manufacturing and healthcare. And it's easy to see why. By beaming information directly into the eye, the wearer can work on complex tasks all while absorbing crucial information hands-free.
It's actually lasers in the side here that's bouncing off. If you get it just right, you can actually see a little mirror here. It's kind of hard to see.
Oh,
but
yeah.
You get it? Yeah.
Yep.
And so it bounces off the lens and back into your eye.
That's so cool.
Breakthrough technology like this is getting smaller every year. Even now, it's being developed for contact lenses. The Mojo lens is less bulky than smart glasses and completely invisible to others. When paired with a smartphone, they not only display information for the wearer, but also improve eyesight.
In the future, we'll see the technology disappear, it become widespread.
To bring man and machine even closer into alignment, Thad is developing another cyborg technology that actually teaches the body and brain new skills with no training or practice required.
This idea of being able to passively train these skills is something that's new. We haven't heard of it before. These are what's called muscle memory gloves, and they teach you skills like how to play a piano without your active attention.
How does it simulate? What's happening?
Okay, so let me show you the glove here. So what we got in here are little vibrating motors that are above the fingers.
Oh, things are happening.
Yep.
These vibrating motors emit a particular sequence on my fingers. This stimulates and trains the muscles in my hand to do something I've never done before: play the piano.
So she has the glove on right now. And what it's doing is it's using the vibration motors to actually tap each finger in the sequence of Beethoven's Ode to Joy. You will have that muscle memory in your brain.
After the glove has trained my hand for a half hour, it's time to see if it worked. I don't play the piano, so this will be interesting.
Okay.
So let's take off the glove here. She's gonna put her hand down, and we'll see if she can do it. We're kind of excited to see what happens. And you're gonna start there.
Okay.
So try your hand, right?
Having never learned to play the piano before, I've gotten the hang of it pretty quickly. By training the muscles in particular ways, these gloves rewire the brain, giving the user a jump start in developing fine motor skills for just about anything.
And we've been able to do that not just for piano pieces, but also for things like typing, for Braille.
Muscle memory gloves are already changing lives.
One of the things we're excited about is the rehabilitation side of these gloves. We can help people who have had partial spinal cord injury.
Like this man. The glove is even rehabilitating muscle coordination for people who've experienced strokes.
You can actually stimulate the hands such that people regain some sensation or dexterity. I really believe that these on-body devices are going to make us more powerful, more independent.
Wearables like these that augment the mind and train the body with new skills will usher in a cyborg future for all of us.
In the future, doctors wear muscle memory gloves in advance of complex surgeries to enhance precision and dexterity. The devices are tailor-programmed for each procedure to passively train the surgeon's hands. During the operation, augmented reality contact lenses provide a dynamic 3D roadmap of the patient's body. As a result of these protocols, success rates are soaring above 98%.
External machines won't be enough to make the merging of man and machine complete. We'll need to surgically integrate the technology inside our bodies. To experience this integration myself, I'm outside Seattle to meet a controversial biohacker. He's offered to implant a computer chip inside my body.
I'd heard a lot about it from some other people that I had met within this transhumanist community, which is like a group of people who believe in changing and upgrading your body.
Like most transhumanists, biohacker Amal Grafstra believes technology will fundamentally change the human species, helping us evolve beyond our current physical and mental limitations.
I'm improving the human body by implanting simple devices into it and then change my capabilities as a human being. That's biohacking.
Amol has turned himself into a lab rat for his own inventions. He has 5 functional devices implanted across his body.
So,
Those are implants.
These are implants, yeah. So they would just go, you take a 4-gauge needle, make a pocket, and then just slide it in.
Very cool.
There it is. So this is the new size of this prototype, this huge one.
Yeah.
Giant 35mm diameter implant, right?
That's a big one.
That's a big one. I've had it for a while.
Each chip serves a particular purpose.
This is like a payment card from the EU. I'm converting them into implants for people.
Imagine that, paying with the swipe of your hand. But integrating machines into our bodies has led to a lot of resistance.
So from when you first started out, do you feel like people have gotten more receptive?
In general, yes. So in 2005, when I put this in my left hand, the first one, the reactions were very visceral.
Right.
What are you doing? You're crazy. Oh, we should get him, he's supporting the government New World Order. That kind of thing. And now, you tell somebody on the street, I got a chip implant, they're like, oh, I heard about that.
However, as society becomes more receptive to the idea of cyborg technology inside the body, new ways of using it will emerge. By incorporating magnets into his body, Amol has found that he's created an entirely new biological faculty, giving him an unprecedented sixth sense.
Your magnet you were able to feel the fields.
Yeah, magnetic field.
You adapted to that.
But yeah, you adapt to it immediately. And that, to me, again, says that this is part of who you are now.
The implanted magnet rewired how his brain and body experienced reality, giving him a new magnetic sense.
I took it out after about a year, and there was a real sense of loss.
Amol's not the only one out there in these uncharted waters. Cyborg artist Neil Harbison has a cyborg antenna implant, which senses colors, including ultraviolet and infrared. The implant allows him to both feel and hear colors as vibrations inside of his head. Engineer Kevin Warwick had a chip implanted in his arm that directly connected his nervous system to the internet. It's clear we are already on the path towards the full integration of man and machine.
Where do you think, technology is going in general?
On one hand, it's very exciting and cutting edge, but also it's nothing new. Like, human beings have always been leveraging technology since we picked up rocks and sticks, right? It's just that technology's been external. The technology that's gone into our bodies has always been kind of medical and restorative.
Right.
And this is an enhancing, augmentative technology. So there's some trepidation about breaking the skin barrier for a non-medical need, right? But overall, the trend for human beings is to make technologies that enhance our capabilities.
With my bionic arm, I know this to be true firsthand. But getting another enhancement under my skin, I'm not so sure about.
You ready?
I am,
Yes?
I'm ready, yes.
Okay.
The answer is yes.
The answer is yes. Okay, good. Here we go.
Amol is implanting a VivoKey chip into my fleshy hand.
Take a deep breath. Here we go. Yay.
This new implant will give me a unique electronic signature.
Very cool.
With it, I'll be able to unlock all kinds of devices and pay for things with a simple swipe of my hand.
I think that it's going to be a point where everyone's chipped at some point.
There's going to be something. It might not all be the same chip. Some people might have like a glucose reader.
Right.
Some people might have something else. Some people will have a cognitive implant. It's to the point where we can just put it in our bodies and it becomes part of who you are now.
Yeah, I love that.
Let's see if this thing actually works.
So go ahead and press the button. And now back of your hand across there. Just like that.
Cool.
Integrating chips like these into the human body will unlock doors to our cyborg future.
In the future, multi-feature chip implants the size of a pinhead replace most wallets and mobile phones. Everyone just swipes their hands to pay, unlock everything, and confirm personal identification. The magnetic sensor enhances orientation, operating like a compass. It lets users feel direction. No one ever gets lost. Biosensors measure vital signs and blood chemicals. At the first sign of a health issue, physicians are notified for preemptive treatment.
It's pretty easy to see how cyborg technology can improve the body. But integrating it into the human brain is a far more complicated and dangerous task. Neuroscientist Dr. John Donahue is forging the difficult path to this very future.
We're in Providence to meet with Dr. John Donahue, talking about implants. Like I have the implant in my hand. He puts them in your brain.
John led a pioneering team that created one of the first brain-computer interface devices. It's called BrainGate.
We actually peer into the brain and look at thinking about movement. When we first put an electrode in the brain, we didn't know whether somebody could control anything.
To decipher the connection between thought and action, John implanted the BrainGate device into Matt Nagel, a quadriplegic. Matt was able to control a computer cursor directly with his mind.
So the whole idea of a brain-computer interface is to help a person who is paralyzed to be able to move again or be able to communicate or interact with the world.
Open.
John achieved this breakthrough by using computers to read the brain signals inside Matt's skull. The first technology to do this was developed in the 1920s by German psychiatrist Hans Berger. He invented an instrument he called the electroencephalogram, or EEG. The device measures the brain's electrical activity through the skull and represents it as complicated lines on a graph. However, decoding these brainwave patterns is an immense challenge, especially when the goal is to control complex movement.
Imagine that those signals coming from your hand to control that were not coming from your hand, but from your brain. And now you don't know what makes your brain cells active, so how can you relate what your brain cells are doing to that motion? And we didn't know whether anybody could ever learn to do it.
With BrainGate, John took the next very difficult step of deciphering a person's mental intention to move their body.
So the first thing we have to do is we have to go to a place in the brain that has those signals. Then we need to be able to sample the activity in the brain.
This involves surgically implanting tiny electrodes in the region of the brain that controls movement, the motor cortex. The electrodes directly observe and measure the activity of the neurons located there.
Each neuron talks to lots and lots of other brain cells, other neurons, and it creates electrical impulses that are the communication language of the brain. Each one influences the other, and collectively they generate patterns of activity.
And the tiny electrode array picks up these patterns.
This electrode array is basically 100 needles.
Oh my gosh.
Yeah. So each one of these is what the electrode is recording, and that is the electrical impulse of the neuron emitting its electrical impulse. So we actually aren't trying to interpret just that cell all by itself, but how does it fit in everything all together? It generates a pattern.
Understanding this pattern is like putting together a 1,000-piece puzzle without a picture for reference.
Our job is to take a look at all of those activity patterns and try to make sense of what they actually mean. And what we use is a computer to translate. It is really like translating a foreign language. And so what we do is we tell the computer, basically, when you see the pattern that was recorded when the person thought about moving left, if you see that pattern again, then move to the left or move a computer cursor to the left.
Using artificial intelligence, John can translate those brainwaves into a physical action far more complex than just moving a cursor. Kathy Hutchinson, who was unable to move or speak because of a stroke, was the first person to use BrainGate to control an external robotic arm and hand. This leap forward will change the lives of countless people. But there's a big problem. The electronics required to amplify and translate these brainwaves are the size of a washing machine. How will technology like this integrate into the body to create a self-contained cyborg? John has the beginnings of a solution.
This wafer, which is something like 4 by 8 millimeters, it has 1,000 electrodes on it. But what's even cooler, that little square is equivalent to 10 of these things, all on a chip. What do we need to do to implant this into human? We have to figure that out. Then we have to ask users, what do you want? If it has to be something sticking up like a box on your head, Actually, I worried that you would say that's cool.
You know me so well already.
But most people wouldn't want to do that. You know?
Even though chips like these are small, they'd still need to connect to external computers with a tangle of wires.
Given that electronics can do this, that neuroscience is not quite up there, but we're pretty good, that all of that information pooled together will get us there. We can do it.
The Cyborg Revolution depends on advanced versions of integrated brain interfaces like this to read our most complex thoughts and intentions. But making devices like this that stand alone in the brain is not as far off as one might think. In a nearby lab, engineer Arto Nurmiko is developing tiny chips that will not only interface with the brain, but connect wirelessly.
So the first thing is to cut the cable in order to particularly endow more mobility for a subject. So he or she is not tethered to these massive volumes of electronics.
He calls these prototypes neurograins.
They look like glitter.
What they are individual tiny little chiplets about the size of a grain of salt each. And they have internal electronics. There we go, that's neurograin. The physical size means that there is safety in implanting such tiny little objects in the brain without causing damage.
Thousands of neurograins could be distributed across the surface of the brain to record and broadcast neural activity wirelessly.
Each one of these little chiplets would be like a little cell phone that's able to capture some of these neural signals and then spew them out, streaming your thoughts in real time.
That's wild to think about.
Using computers, Arto is developing cutting-edge techniques to interpret these complex signals.
We use machine learning to decode or understand what those 10,000 little cell phones are actually telling you or me about my intention or your intention, not only to move an arm, but perhaps do much more complicated movements.
This same technology could also be used like a two-way radio, not just sending, but receiving thoughts as well.
If we project forward and begin to contemplate, or at least imagine the possibility of using electronic methods of communication with the brain for people who don't have any particular disability.
Right, enhancements over restorative.
Right, exactly. So that's how the concept has taken its first steps toward reality.
It's really cool.
Connecting the brain with machines, allowing a person to send and receive thoughts, would be a monumental breakthrough.
In the future, brain implants replace computers and connect wirelessly with the internet. Electronic communications like emails and text messages are composed and sent using thoughts alone. Mental snapshots and dreams can be uploaded to the cloud and shared with friends. Every word in any language, written and spoken, is directly translated and accessible to any brain. Now that humans off-source mental chores like memorization, the full potential of the human brain is unleashed.
Throughout human history, so-called psychics have claimed, dubiously, that they can read people's minds. But as we blaze a trail to the cyborg future, reading thoughts, aided by technology, seems more and more possible. But how would that kind of telepathy work? I'm in Seattle to meet Dr. Rajesh Rao, who's actually developing science-based telepathy.
We began thinking about this idea of extracting information from a brain and send it to a different person. Computer-assisted telepathy, brain-to-brain communication.
This radical technology lets individuals use computers to telepathically control other people.
So what kind of reaction have you gotten to your research? Do people think it's cool or kind of scary or?
All of that, actually. So you had reactions ranging from, it's amazing, it's cool, it's so sci-fi, to people who are scared about this kind of technology.
But when people adjust to the concept, this is what the cyborg future will look like.
Are you ready to interface?
Yeah, I think so.
And I'm going to give it a try.
So you'll be wearing a brain-computer interface cap that will be tapping into the electrical signals that we're measuring at your scalp, which in turn reflects the underlying brain activity.
Oh, wow, look at this room.
Rajesh's team fits me with a 32 electrode EEG cap. The cap will observe and measure the electrical activity of my brain.
All right, great. So right here, and I'll manage these wires.
The computer reads the signals from the EEG cap to interpret my intentions. Does this look cool? Do I look cool?
Oh, yeah.
Yes.
You look like you're from the future. Even more so.
Even more so. I was like, yeah. My mission is to play a video game through another person using computer-assisted telepathy. If this works, my brain will actually control the other person's body.
Oh, we're almost there, Preston. 11. I think we're good.
We're good?
Yeah.
And here's the kicker. The other player will not see the video game at all.
So what we're going to do is have you control a cursor on a computer screen, and that message is going to be sent over to Jane here.
So Jane will be receiving your thoughts through this TMS, transcranial magnetic stimulation device.
Yeah, I'm excited to feel your brainwave.
All right, let's figure this out. The TMS device uses pulses of magnetic radiation to stimulate the neurons in Jane's brain.
It'll send a message to the motor cortex region of her brain, and that in turn will cause her hand to move. And in turn, it'll allow her to, play a computer game that she's not seeing.
Let's see if this wild contraption works. My goal is to use my thoughts to control Jane's hand.
If you want to send a yes signal, you just pay attention to the left light. And by focusing on that, the ball should move to the corresponding direction.
By concentrating on the area of the screen that says either yes or no, I can move the cursor left or right to indicate my choice just by thinking about it. When I select yes, Jane will receive the stimulation in her brain from the TMS device to click her computer mouse.
No stimulation.
Now it's time to see if I can send a signal to Jane's brain just by thinking and selecting yes.
Yes.
Really?
Yeah.
What did you feel?
There's a little tap at the back of my head, and then my wrist and my fingers just moved.
Using my thoughts alone, computer-assisted telepathy lets me control another person's physical movement.
I know I'm not thinking to move it, my hand just moves. It's like a reflex, like when someone kicks your knee and it just moves. That's what it feels like.
That's so weird. Rajesh is using this technology to forge a cyborg future even more mind-blowing.
Our goal is to connect brains together such that the connected brains can solve a problem that none of the brains individually could solve.
Networking the minds of entire communities and industries together could radically transform society. As the plan to have more people to have the whole net kind of thing?
Yeah, so in the future, maybe you can unleash the kind of creativity that a single person cannot. So by having many brains collaborate on a project together, perhaps you can solve very hard problems.
By networking brains with complementary strengths, the whole would be greater than the sum of its parts. And with this kind of mind-melding cyborg synergy, humankind might invent new forms of green energy and reverse global warming, decipher the mysteries of human consciousness, or even answer the question of what happened before the Big Bang. The sky is no longer the limit. But with any new and disruptive technologies, society needs to weigh the benefits against the risks. How cyborg technology will change the world is unpredictable.
As with any device, we need to look at the privacy and safety issues, more so in the case of brain-computer interfaces, because it has the potential to change who you are.
It's easy to take for granted that the contents of our brains belong to us. But in the cyborg future, that might not be the case. That personal, private information that makes every person unique could potentially be abused.
In this world of neurotechnologies, ethics is hugely important. You could call the invasion of your brain as being the ultimate sacrifice or ultimate leap. Or you could say, well, it's just another increment in the pathway of losing the ultimate privacy, which is the privacy of your own thoughts.
And in the future, who will benefit from things like cognitive enhancement? Will the privileged be the only ones that can afford to download a lifetime of learning into their children's brains? Or will everyone gain access? The Cyborg Revolution has the potential to upend society. But many are excited about the transformative possibilities of a cyborg future.
Let's imagine we're linked neurally, right? Yeah. We lose the language completely, and now it's just thoughts and feelings and concepts, and like, who knows, right? So it could definitely fundamentally change humanity.
I really believe that this technology can, when it becomes part of us, make us more of what we really are, which is human.
Despite some valid concerns, I'm hopeful that science, technology, and the human spirit will find helpful solutions. As for me, I expect everyone will become a cyborg one day. And I can see a future where individuals choose to upgrade their physical body parts with robotic ones once they have better features. The cyborg revolution is coming. And as a cyborg myself, I couldn't be more excited.